Number 10 looks fairly similar to number 9. Again, it's going to be cubic because the highest power of x is 3, but then we've added in this squared term as well, so let's see how that changes the graph. Plug in -2, I get -8. I'll go ahead and keep track of this over to the left. X equals -2 gives me a -8, and then -4 times x squared is -4 times 4, so that's -16. That gives me -24. Plug in 0, 0 minus 0 is 0. Plug in 2, that gives me 8 minus 4 times 4, so I get -8. When I plug in 4, 4 cubed, well, 4 times 4 is 16. 16 times 4 is 64. And then here I've got another 4 cubed. I've got 4 times 16 is 64. So altogether I get 0 there. Now when I plug in x equals 6, I know x squared would be 36, and then 36 times 6, you may or may not have that in your head. If you don't have it in your head, that's fine. Just come over to the side, multiply it out like you did back in elementary school. 6 times 6 is 36. 6 times 3 is 18. But I add the 3, that gives me 21. So I get 216 for x cubed, and then minus 4 times 36. 4 times 6 is 24. 4 times 3 is 12, plus 2 is 14. All right, you can do that in your head if you want to, or you can go ahead and write it out. (21 minus 14 is 7. All right, so these are the y values I need to plot. They're larger than the ones that I've been used to so far. That's okay, I'm just going to scale my y-axis a little differently. My x values go from -2 to +6, and then they're going up by 2s. 2, 4, 6, -2. Then the y values go down to -24 and up to 72. 24 plus 24 is 48, and 48 plus 24 is 72. So 72 is 3 times 24. So I'm going to put a mark down. This will be my 72. And then if I cut this into thirds, then this will be 24. And that's useful because now when I go down, I can just sort of eyeball this and say -24 is about here. All right, and then I need a -8 on y value as well. That's a third of -24, so I'll cut this up into thirds. And there's -8. All right, let's plot these points. -2, -24, 0, 0, 2, -8, about right there. 4, 0, 6, 72. All right. So first, the way I've scaled these, my graph is not going to be perfect because I'm cutting this into thirds and then cutting that into thirds. That's okay. Don't worry about that. I just want to make sure I get the basic shape of this graph. So it looks like as I come from the left, it's going up, and then when I hit here, it looks like it starts to go down and then back up and keeps going up. And that makes sense. What I mentioned up here is that if I take this x cubed and add more stuff to it, it can put some wavy stuff in the middle. It can also shift it around a little bit, but the basic shape is still the same. You come up from the left, you do some stuff, and then you go up to the right. So it looks something like this. The shape, again, I'm going to call it a cubic or a twisted parabola, whichever you prefer. The y-intercept is the origin again. Remember, the y-intercept is where you hit the y-axis. Do the y values increase or decrease as x approaches infinity? As I go to the right, my y values are going up, so they increase. And do the y values increase or decrease as x approaches negative infinity? As I go out to negative infinity on the on the x-axis, my y values are going down, so they decrease.